Hi, good morning. Today we have to discuss a new chapter, differentiation. This chapter is already learned in our first year classes. This year we have to discuss five different types of differentiation. First is a derivative of function of function, implicit functions, parametric differentiation, logarithm differentiation, and second order derivative. Usually, the derivative means the rate of change of a function. Derivative of function is possible at a particular point of the domain or throughout its domain. But suppose a function is differentiable throughout its domain, then the function is to be differentiable function. Now, y is equal to f of x is a function. For finding the derivative of this function, we use a formula. That is dy by dx equal to limit h tends to 0 f of x plus h minus f of x divided by h. F of x plus h minus f of x divided by h. We find the derivative of many functions using this formula is called derivative using first principle. We find many functions such as polynomial function, exponential function, logarithm function, trigonometry function, inverse trigonometry function, all functions. We find the derivative of all these functions using this formula. And we find a derivative of such a function using this formula is called derivative using first principle. First of all, I want to find the derivative of some function. First we find the derivative of x raised to n. The function f of x is equal to x raised to n. For finding the derivative of this function, first we find f of x plus h. That means we replace x by x plus h. That is x plus h the whole raised to n. Now we use the formula dy by dx is equal to limit h tends to 0 f of x plus h minus f of x divided by h is equal to limit h tends to 0. F of x plus h is x plus h the whole raised to n minus x raised to n. F of x corresponds to x raised to n divided by h. Now applying limit, we get an indeterminate form. So here we expand x plus h the whole raised to n using binomial theorem. The binomial theorem, a plus b the whole raised to n equal to nc0 a raised to n plus nc1 a raised to n minus 1 into b plus nc2 a raised to n minus 2 into b square plus etc. plus ncn b raised to n. Using that theorem, we get x plus h the whole raised to n is equal to nc0 x raised to n plus nc1 x raised to n minus 1 into b. Here b corresponds to the value h plus, write one more time, nc2 x raised to n minus 2 into h square, etc. And our last term is ncn h raised to n. nc0 and ncn are always equal to 1. So here you write only h raised to n minus second term x raised to n the whole divided by h. Here the value of nc0 is 1 and therefore 1 into x raised to n and x raised to n are cancelled. Now the balance term contains h as a common term. You take h is common. Therefore the value of nc1 is n into x raised to n minus 1 plus nc2 into x raised to n minus 2 into h square. Here you take h as a common term, etc. And our last term is h raised to n minus 1 the whole divided by h. Here h cancel. Now we apply limit. in the fraction form, you take h as any term, you take a common term and then cancel. When we apply limit, we get a definite value. That means all these terms are tends to 0. And balance answer is n into x raised to n minus 1. That means derivative of x raised to n, we get answer n into x raised to n minus 1. Similarly, we have to find the derivative of some other functions. Now, we find the derivative of f of x is equal to root x, that is a radical function. F of x equal to root x. You know, f of x plus h, that means replace x by x plus h. Now use the formula dy by dx equal to limit h tends to 0 f of x plus h minus f of x the whole divided by h. That is equal to limit h tends to 0. Here what is f of x plus h? Root of x plus h minus root x the whole divided by h. Suppose you apply limit, we get an indeterminate form. So, finding a definite value, here we multiply the numerator and denominator by the conjugate of this term. You know the conjugate of this term, root of x plus h minus root x the whole divided by h into the conjugate of the radical term, that is root of x plus h plus root x divided by root of x plus h plus root x. That is equal to limit h tends to 0. On numerator is of the form a minus b into a plus b. You know, a minus b into a plus b is equal to a square minus b square. And therefore, root of x plus h the whole square minus root x the whole square is x plus h minus x. Because root of x plus h the whole square is x plus h minus root x the whole square is x. The whole divided by h into root of x plus h plus root x. Here x cancel. That is equal to limit h tends to 0. H divided by h into root of x plus h plus root x. Again h cancel. Then we apply limit. We get a definite value. On numerator we get 1 divided by, as h tends to 0, root x plus root x. We get the answer 2 root x. That means we find the derivative of root x. That is d by dx of root x equal to, we get the answer 1 by 2 root x. Now we have to discuss the derivative of another functions. That is exponential and logarithmic function. Before we find the derivative of this function, first we find the limit of some function. That means first we find limit x tends to 0 e raised to x minus 1 divided by x. We find the limiting value of this function, that is limit x tends to 0 e raised to x minus 1 by x. And second is limit x tends to 0 log 1 plus x divided by x. These two functions has limiting value is 1. That means limit x tends to 0 e raised to x minus 1 by x is equal to 1, and limit x tends to 0 log 1 plus x by x is also equal to 1. Here I present a proof of these two limiting functions. That is, first we take limit x tends to 0 e raised to x minus 1 by x is equal to 1. Here, first we consider an exponential series. An exponential series means here 1 plus x by 1 factorial plus x square by 2 factorial plus x cube divided by 3 factorial plus etc. to infinity is called an exponential series, and which is denoted by the symbol is e raised to x. We substitute this function, this exponential series to the given limiting function. That is, the limit x tends to 0 e raised to x minus 1 by x equal to limit x tends to 0. The series e raised to x is 1 plus x by 1 factorial plus x square by 2 factorial plus s cube by 3 factorial plus etc. to infinity minus 1 the whole divided by x. Here 1 cancel. Now we take x as common factor. We take x is a common factor. Therefore we get x 1 by 1 factorial plus x by 2 factorial plus x square by 3 factorial plus etc. to infinity the whole divided by x. X is cancelled. Now apply limit. All these terms are tends to 0 and therefore we get final answer 1 by 1 factorial is 1. And limit x tends to 0 e raised to x minus 1 by x is equal to 1. Similarly, we have to prove that limit x tends to 0 log of 1 plus x divided by x is also equal to 1. That is, limit x tends to 0 log of 1 plus x the whole divided by x is also equal to 1. Here it's also present the proof. You know, log 1 plus x. Log 1 plus x is a series. That is, x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 to infinity. This series is called logarithmic series, and which is denoted by symbol is log of 1 plus x. These two series, exponential and logarithm series, are already exist in your class table. Now we substitute this series to the left side. That is, limit x tends to 0 log 1 plus x the whole divided by x equal to limit x tends to 0 log 1 plus x means x minus x square by 2 plus x cube divided by 3 minus x raised to 4 by 4 to infinity the whole divided by x. Here we take x as common. Therefore, x into 1 minus x by 2 plus x square by 3 minus x cube by 4 to infinity the whole divided by x. Here x cancel. Now apply limit. All these terms are tends to, as x tends to 0, all these terms are tends to 0 and balance answer is 1. That means limit x tends to 0 log of 1 plus x divided by x is equal to 1. Using these two limit, we find the derivative of exponential and logarithmic function. Now we find the derivative of this function. First we consider the function f of x is equal to e raised to x. Now the f of x plus h is equal to e raised to x plus h. For find the derivative, first you write the formula. Dy by dx is equal to limit h tends to 0 f of x plus h minus f of x the whole divided by h. That is equal to limit h tends to 0. What the value of f of x plus h means e raised to x plus h minus f of x is e raised to x the whole divided by h. Apply limit, we get an indeterminate form. So here limit h tends to 0 e raised to x plus h and split into two forms. That means now a raised to x plus y is equal to, condition is a raised to x into a raised to y. Using that result, we get e raised to x plus h is equal to e raised to x into e raised to h minus e raised to x the whole divided by h. Now here we take common, as e raised to x is a common type. Therefore, e raised to x into limit h tends to 0 e balance term e raised to h minus 1 the whole divided by h. Here we take e raised to x as a common term. Now we apply limit. You know, limit x tends 0, e raised to x minus 1 by x is always equal to 1. And therefore, limit h tends 0, e raised to x minus 1 by h is equal to 1. Therefore, the answer is e raised to x into 1 equal to answer e raised to x. That means the derivative of an exponential function e raised to x is equal to e raised to x. Now find one more function, find the derivative of one more function, that is log x. Log x. F of x is equal to log x. For finding the derivative of this function, first we find f of x plus h. F of x plus h means log of x plus h. Again we use same formula, dy by dx is equal to limit h tends to 0, f of x plus h minus f of x the whole divided by h is equal to limit h tends to 0. You know, f of x plus h log of x plus h minus f of x is log x the whole divided by h. Apply limit, we get an indeterminate form. On numerator, we change it. We use a result. In logarithm function, we use a formula log a minus log b is equal to log a divided by b. Log a minus log b is equal to log a by b. Using that result, on numerator changes the form log a minus log b. Here a corresponds to x plus h and b corresponds to x. And therefore log a minus log b equal to log a by b, that is log of x plus h divided by x the whole divided by h. That is equal to limit h tends to 0 log of x by x1 plus h by x the whole divided by h. You know, limit x tends to 0 log of 1 plus x the whole divided by x is equal to 1. This function is not in the form log of 1 plus x by x. Here x corresponds to term h by x. So we find h by x on denominator also. You already know, as h tends to 0, dividing by h we get answer h by x is also tends to 0. So the limiting value has not changed. So h tends to 0 changes into h by x tends to 0. Numerator is log of 1 plus h by x the whole divided by denominator containing only h. Now multiply and dividing by x. Therefore, limit h by x tends to 0 log 1 plus h by x divided by h by x into 1 by x. The value of this limiting values tends to 1 because which is of the form limit x tends to 0 log 1 plus x by x. That is 1 into 1 by x. You get answer 1 by x. That means the derivative of log x d by dx of log x is equal to 1 by x. We already learned four functions, derivative of 4 functions. First is x raised to n. Derivative of x raised to n is n into x raised to n minus 1. Second is root x is 1 by 2 root x. E raised to x. And the derivative log x is also equal to 1 by x. Now some home assignments are given. Please try to answer these questions. Using first principle, find f of x is equal to x square plus x plus 1, f of x is equal to x cube plus 2, f of x is equal to 8x minus 3, f of x is equal to root of 3x plus 1, f of x is equal to root of 5x plus 4, f of x is equal to e raised to 3x, f of x is equal to log 2x. Next class, we have to discuss find the derivative of some trigonometric functions. Then we enter into the topic chain rule, implicit function. That's all.